Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room. This is where a team keeping track of space station operations is now working its second day of support to the 3 members of the crew of Expedition 58. Station Commander Oleg Kononenko, flight engineers Anne McLean and David St. Jacques have just started a 2-month stretch in which they'll be a smaller than normal sized group, thanks to the departure for home this week of 3 colleagues who spent almost 200 days in space.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Dan Hewitt. 3 crew members wrapped up their year by saying farewell to space and hello to planet Earth. NASA's Serena Aunon Chancellor and her Expedition 57 cohorts Alexander Gerst of ESA and Sergei Prokopyev of Roscosmos packed up their things and left the International Space Station after 197 days in space. Before they left, Alex handed over command to Russian cosmonaut Oleg Kononenko for Expedition 58.
When we close that hatch tomorrow, we'll be both happy and sad. We will leave this place with a laughing and a crying eye, mostly because we miss you, our friends up here, but also this fantastic, magical place.
They loaded into the Soyuz MS-09 spacecraft and undocked for the several-hour journey home. As is typical during the winter months in Kazakhstan, freezing temperatures and snow greeted the crew on the ground as teams from all 3 space agencies assisted in recovering the crew after a successful landing. One short helicopter ride later, they loaded up onto planes and headed back to home base in the US, Germany, and Russia. And while this was the first flight for Serena and Sergei, this was Alex's second long-duration stint on the station, and made him the new record holder for time in space among European astronauts with 362 days total. Phase 3 of an innovative tech demo teaching us how to fuel up in space is underway. Ground controllers used the space station's robotic arm to extract the Robotic Refueling Mission 3 and affixed it to its test location aboard the station this week. The latest evolution of this payload will look to complete an important first: storing and transferring cryogenic fluid in space. Cryogenic fluids are important fuels and coolants for spacecraft, and developing the tools and techniques to top off satellites and spacecraft while in outer space will be a critical skill for prolonging the lifetime of vehicles and supporting crews that embark on missions far beyond Earth. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
The robotic refueling mission is a technology experiment meant to support both present and future exploration efforts, but it's just one kind of the science that's being done on the International Space Station. For example, the station's home to equipment that could help answer some big questions in modern physics. The Cold Atom Lab facility produces clouds of atoms that are 10 billion times colder than deep space. And thanks to the microgravity environment on the space station, we can observe these atoms for much longer than we could on the ground. Whether it's science operations or a crew departure or whatever, it takes a big team to ensure that space station operations go smoothly. The lead flight control team for the International Space Station works right here in Houston, and the flight director holds the overall responsibility to manage and carry out all human spaceflight missions and coordinate NASA's work with those of the partner agencies. Earlier this summer, NASA named 6 men and women who are now training to join the flight director team. The astronauts on the International Space Station support all kinds of scientific research in the vehicle's laboratories while they work to maintain station systems to support that science. Well, they also do experiments for the benefit of school students on Earth. Astronaut Ricky Arnold added this demonstration video to the collection that gives us a unique look at how the molecules that make up water behave in space.
Well, Welcome to the International Space Station. I'm NASA astronaut Ricky Arnold. Our view from the ISS of Earth is absolutely magnificent, but we quickly realized we really should call it Planet Ocean. We are mostly a water planet. Water occurs here in all three phases, solid, liquid, and gas. And the presence of water on other planets and moons within our own solar system has us wondering, is there life there too? Well, why is water so special? One reason is called surface tension. So what is surface tension? Let's have a look. Surface tension is a property of liquids in which molecules of one substance are more attracted to each other than to molecules of another substance. Water is unique in that it has a high surface tension compared to other liquids. This is due to its polar property. The positive hydrogen ends and the negative oxygen ends create a strong bond. As they say, opposites attract. So the hydrogen end of the water tends to stick to the oxygen end in a nearby water molecule. At water's surface, its molecules are only attracted to the water molecules below and to the sides of them, as there is only air above these molecules. So the surface molecules of a body of water are pulled down, creating a more stable, stronger environment. That is why certain animals, like the water strider, can actually walk on the surface of water. Here on the International Space Station, the microgravity environment makes it easy to show how well water uses surface tension to stick together. We even rely on surface tension to help us wash our hair, those of us that have a lot. Thanks for coming along today and learning a little bit about surface tension. Want to learn more about the unique properties of water and do your own experiments? Try out the activity related to this video at the STEMonstrations website. See you next time.
Lessons in space during the year of education on station, like the one Ricky Arnold just taught, were designed to take advantage of the presence of a former classroom teacher as a member of the crew to help students and their teachers on the ground with science, technology, engineering, and mathematics. It was an effort that was built on the example set by another teacher more than 30 years ago.
Reach for it. Presented by Science at NASA. In August 1984, President Ronald Reagan announced NASA's plan to send one of America's finest, a teacher, to space aboard Space Shuttle Challenger. Of 11,000 aspirants for the adventure, 37-year-old high school teacher Krista McAuliffe from Concord, New Hampshire, was chosen. As the first teacher traveling to space, she planned to conduct science demonstrations from low Earth orbit to get students, quote, excited about history, about the future, and about space, end quote. Tragically, Challenger broke apart soon after liftoff on January 28, 1986. There were no survivors, and McAuliffe's planned demonstrations were shelved. International Space Station astronauts Joe Acaba and Ricky Arnold have brought McAuliffe's mission full circle by completing and filming on orbit her envisioned lessons as a tribute to her legacy. U.S. crew members aboard the station have also performed and captured other brief, engaging lessons, or STEMonstrations. As part of the Year of Education on Station, NASA has made all of the demos available to classrooms around the world. Chromatography is one of the most interesting McAuliffe lessons Acaba and Arnold have brought to life. It provides hands-on activities for students to understand the importance of capillary action and chromatography, and compare how they work in microgravity versus on Earth. Capillary action occurs anytime a liquid spontaneously flows into a narrow tube or porous material. It's how plants get water from their roots to their leaves. It's how our blood makes a round trip through our bodies. And it's how those paper towels soaked up the orange juice you spilled this morning. Chromatography is a technique that uses capillary action to separate mixtures so they can be analyzed. On Earth, chromatography is used for activities such as studying samples at a crime scene. Chromatography is an essential technique for spaceflight, too. For instance, keeping crew persons safe from contaminants includes analyzing unknowns, which can be critical on long space missions. An example of a year of education's demonstration features NASA astronaut Randy Bresnik slingshotting objects of all sizes across the inside of the space station with a bungee cord. He's illustrating how Newton's second law of motion holds true in microgravity, just like on Earth. Simply put, Newton's law states that the greater the mass of an object, the more force it will take to accelerate it. Year of Education on Station also included more than 60 opportunities for hundreds of students and teachers to connect via in-flight education downlinks with astronauts aboard the space station for live question and answer sessions. Participants asked questions about all aspects of living and working in space.
Hi, my name is Ramsey, and my question is, have you ever had the idea to get a lot of water, pour it out, and see what happens?
See how it just sticks to my hand? It just waves there. It doesn't really go anywhere. It just sticks right to the surface, so I could drink my lemonade right from my hand.
How do you grow plants in microgravity without soil and water getting everywhere?
One of the plants actually uses pillows that are impregnated with moisture and the nutrients they need. We have another advanced plant habitat that I've been working on where there's a reservoir in the water. It's all very controlled, pretty much soil-free. The important thing is nutrients and water.
Hi, I'm Lexi. Would a yo-yo work in microgravity?
I didn't have a lot of time to practice, so here we go. My first yo-yo. So it works, but it's a little bit different. So thanks for the question and letting me find out if they do work.
With the Year of Education on Station, NASA's goal was to do what Krista and her optimism did so well: inspire students and teachers to, quote, reach for it, push yourself as far as you can, end quote. For more on NASA's Year of Education on Station, go to www.nasa.gov/STEMOnStation. For other inspiring NASA happenings, visit science.nasa.gov.
Some of the crew members on future International Space Station expeditions will make the journey to and from low Earth orbit on spaceships launching from the USA. The astronauts assigned to the first crewed test flights in the Commercial Crew Program have been busy all over the country, getting familiar with their new spaceships and training for their historic first flights, which are targeted to happen next year. Here's some of what it looks like as the astronauts get themselves prepared for their next trip to space.
We've had the opportunity to try on the suits, to sit in the seats, to interact with the displays, the emergency egress systems for any type of emergency egress from the pad. It's been pretty fun, actually, checking out all the hardware.
Because NASA has not done a flight test program for a spaceship since the space shuttle. So you're talking late 70s, early 80s, the last time we kind of did this as an agency. So some of it is kind of relearning those techniques and those things that you need to make sure you're watching out for.
We'll be brushing up on all the long-duration spaceflight tasks that we've trained for over the years, including spacewalking and robotics and all the space station systems.
But then we're going to learn all about the new vehicle, all about our suits, how we're going to operate in that vehicle, emergency procedures.
You're going to have kind of this hybrid, if you will, for these first flights where you're helping develop things and at the same time you're getting training.
We're going to be building what it is the crew member needs to know.
Things that are really neat to me that are new is putting on a new spaceship, putting your arms into it and actually getting to touch the screens, just like you did as an operator when you're going into space.
So those skills that we honed in test pilot school and then later on as test pilots, I think they're going to be put to use in flying these vehicles. It's a new set of hardware and it's a new set of software.
For all the folks that are following along throughout the world, I really would like them to recognize that there's a huge team that makes this possible, that when I get the opportunity to board one of these spacecraft and fly into space, that I will have been propped up by a team of engineers that made this happen.
While commercial spaceships join the fleet, bringing crew members to the International Space Station, NASA will also be pressing ahead with development of the hardware that'll take astronauts into deep space down the road. Here's a breakdown of the elements that will support NASA's plans for moving out beyond low Earth orbit.
So you want to go to Mars. How do we send humans to deep space? In order for humans to explore the Moon, Mars, and beyond, we need safe, flexible, and powerful systems that will make it all possible. We start with the world's largest spaceport. At Kennedy Space Center, we have all the buildings and tools needed to assemble and launch space vehicles, and have the teams in place to recover the astronauts when they come home to Earth. Next up, we need a deep space rocket. This is NASA's Space Launch System. It will be the most powerful rocket NASA has ever built, and it has the muscle to lift people and all of the equipment needed for missions to new worlds. The Space Launch System will blast off with the crew in the Orion spacecraft. The most advanced spacecraft ever built for human exploration, Orion provides the life support, power, communications, and other systems to safely transport astronauts on a variety of exploration missions, like to the Moon. In lunar orbit, we will learn to live and work in a deep space environment, something we have never done before. In future missions, NASA's Gateway will be a place for astronauts to live, work, and prepare for missions deeper into the solar system. There you have it. NASA's Deep Space Exploration Systems, charting our new future in space. To find out more about deep space exploration, visit this NASA website.
The historic year 1968 was closed out by NASA with a first-of-its-kind accomplishment, putting human beings in orbit around Earth's moon, which is a feat that also provided the people of Earth with their first-ever view of the planet from afar. Join me to recall the events of 50 years ago that forged the path to those first footprints on the moon.
It's hard to believe it's been 50 years since NASA embarked on an amazing journey in which 3 humans left the planet Earth for the first time to visit another celestial body. Through coincidence and orbital mechanics, this journey would fall over Christmas time, the epic journey of Apollo 8. 'Twas T-10 with the world looking on, 3 brave souls prepared an epic journey at dawn. The rocket was stacked on the pad so precise, with oxygen billowing neath tanks wreathed in ice. Launch controllers were nestled at consoles so near, watching temperatures, voltages, making sure all was clear. Atop the Saturn, 300 feet high off the ground, the astronauts faced skyward, where they'd shortly be bound. Destined to fly to parts far and unknown, the first humans in history to truly leave home. Around our neighbor they'd circle before turning back, returning home to the blue marble suspended in black. As the seconds ticked down, the rocket rumbled to life, millions of parts humming in a sequence so precise. The world held its breath in awe of the sight as engines awakened and shot forth their first light. An eruption of flame chased by incredible sound, the people of Florida feeling quakes in the ground. The rocket leapt skyward as the world rejoiced, with the mission now heralded by a thundering voice. Now Borman, now Lovell, now Anders, take flight. For Kennedy, for Grissom, for Chaffee and White. To the farthest of reaches, to the heavens beyond, now fly away, soar away, slip free the Earth's surly bonds. Mere minutes passed by, 3 stages dropping away. 2 more hours till it's time for Houston to say, Apollo 8, you are go for TLI. The engines roused from their slumber, Toward the moon they did fly. With stars guiding their way like explorers of old, the brave travelers spiraled on in a barbecue roll. Then 3 days later, they passed out of sight to the far side of the moon and in orbit just right. Around and around the gray landscape they flew, seeing sights for humans all new. Reporting on craters, some round, some bland, so that those soon to follow would know where to land. 4 circuits complete, when to their Christmas surprise, peeking over the horizon, a magnificent Earthrise. There's the Earth coming up, cried Anders enraptured. Then the snap of a shutter, and for all time, history was captured. After 9 rings around the grayish bleak ball, a camera brought the world aboard for a Christmas Eve call. While lunar vistas streamed across millions of screens, the people of this good Earth sat enthralled by that scene. They set sail for the good Earth on their chariot of fire. Houston reporting, there is a Santa Claus, a phrase to admire. It was then 2 days' flight toward a globe growing in size, before a fiery plummet that would light up the skies. Their windows grew hazy as the bright plasma flared, while safe in their chairs, the brave explorers prepared the jolt of the parachutes, and then a long float on down to splash in the ocean, now home, safe and sound. With an end to their journey, they were hailed heroes true, the first men in history to get so close to the moon. Soon thereafter, others would follow in line to continue the greatest adventure across all space and across all time. Happy holidays to all from NASA and from all of us here at the Johnson Space Center.
If you'd like to get another look at any of the stories we feature today, including the new Christmas classic, check us out on YouTube and Facebook. There are the addresses, and you'll see all those features and a lot of other cool stuff about NASA and America's human spaceflight program. And while you're out on the internet, check out Houston, we have a podcast. That's folks here at NASA talking about their work in all aspects of space exploration. The new episodes all post on Fridays. Today, Gary Jordan marks the 50th anniversary of the launch of Apollo 8. With a conversation with an Apollo history expert that includes comments from 2 of the 3 Apollo 8 crew members. Go to nasa.gov/podcasts. You can find today's episode and all the other episodes. Fact is, you can find the full library of all the NASA podcasts all in one place, nasa.gov/podcasts. You can also listen to any of them on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.